Hello there, thank you for joining me again today. On the bench for a strip down and a look at is a Marconi IFR2913E. This is a 500 MHz to 2.4 GHz RF digitizer, and I picked this up a while back from a chap who'd already attempted a repair on it, and I bought it quite cheap because I needed the cabinet parts, you see, for other test gear and power supply and things, because this type of chassis is shared quite commonly with multifunction, multi-output signal generators, and it shares the same innards really for most of it. So I thought, well, it'll be interesting for spares and to have a look. It does work to some extent. The chap who I bought it off has already done extensive repairs on it, but not been successful, and there's been numerous people before him trying to do repairs, which we'll see when we go in it. But it's sort of like a spectrum analyzer really, and then a digital analyzer combined within it. Now at the moment I'm injecting 2 GHz at 0 dBm in, and this is a signal here, so it does work to some extent, but when we look at the markers in a moment you'll see the levels about 34 dBm off. So there's obviously been an issue with an RF input fed in there that's perhaps overloaded it. But basically the port on the left is 0.5 watts or 500 milliwatts rated. The port on the right here is rated to 40 watts. So that can take a fair bit of power really. So it'd be nice to have a look inside. I don't have any service diagrams for this or schematics. No service manual info, so it's probably just a case of you know, whipping the lids off and having a look and see what we can find, and trying to do a bit of reverse engineering, have a look at it, see how it works. I don't attempt to repair it in this video simply because of the fact that you just can't get parts for it. That's why I bought it, for parts for other things like the LCD display and things like that. But it'd be interesting to have a look. I've got some information currently displayed on my computer as to what this instrument does, and basically it says here the 2319 is a high precision RF instrument designed to provide good quality digital conversion of RF input signals. And it goes on to talk about 3G applications, so it's like for cellular system, 2G, 3G bands. It talks about digital IQ, IF data can be output to a choice of interfaces. So it's for analysts with a PC once you've obviously recovered the IFs from the back. Now what's interesting about it is that it works rather like a spectrum analyzer, which is something that attracted me to it. And it's got two functions. It's got basically spectrum and analyze. So under analyze you can go into more detail, and in spectrum mode it just works as an ordinary spectrum analyzer. Now we've got markers as well. If I put the markers on and then we select marker on, we can see then that there's a level. So I'll just zoom in on the screen just to show you, you know, what sort of level we're looking at there. And I think it's marker, let's have a look here. I'll just try and move this rotary control here just to see if we can get the, yeah, so right, if we get it right to the peak there, this is a level here. And as you can see, I mean, we're injecting obviously 0 dBm, and it's you know, minus 36 dBs, so obviously it's way off the mark, you know, and unfortunately that's one of the reasons why this guy tried to repair it and couldn't. You know, it's very difficult to try and fix these sort of faults, but it is very similar in a way to other instruments in this range with the cabinet and everything. So it obviously shares the same cabinet parts and innards to some degree as well, which is obviously quite useful. Down here we've got a port, obviously as I said earlier, that's 0.5 watt maximum, and then a 40 watt port. so it can stand a fair old bit of power. I think it's got a step attenuator in it as well, because if I change the level and put that to 0 dBm, and when you alter the level, I might be able to enter in stuff at neg 50 dBm. You can hear the relay inside clicking, so obviously, you know, it's going through its range. And likewise, when you adjust the rotary control on the level up and down, you can hear it clicking, the step attenuator. So it's quite a fully featured little unit. Now on the analyze bit, you can go into further detail, because obviously we've got frequency, we've got the usual thing, level, and then we've options here, of course, on the screen. If I just zoom in, the units, etc. And then obviously high power input, so you can select the high power input, or you can select the low power input, which we're on at the moment. Maximum sensitivity as well, and there's more options as well there. So what I've done as well on this, just to see if there's a calibration error, I went into the utils function here, and I went into the calibration menu. So you can basically go into do the I think it's under instrument status somewhere, there was a calibrate menu I went into, and I found what the code was to get into the calibrate menu just by messing about, and I tried to recalibrate it using my reference signal generator, you know, just to see if the calibration data was lost, and it just needed recalibrating, which is a reason for the level, you know, obviously not reading correctly. But just seeing if I can find it now. I think is it that one, factory default? It's not that one. I wanted to show you that, but just having a look to see if I can find it. I'm sure it was under utils. So we'll look at this again. Utils, GPIB, time settings, instrument status, options, IFR, defaults, software status, options. What options does it have? IQ, IFR defaults. Just trying to get to calibrate menu. Is it under there? Factory default, instrument preset. It's definitely not under GPIB settings. It's not under there, edit description. It's not under time settings, obviously. Instrument status, key click, software status. It's got to be here somewhere. I'm sure under that power on settings, factory default. So what's that? There was a calibrate thing. Just wondering where the heck it is. Anyway, I've been into this calibrate menu, and as usual, when you want to try and show somebody, you can't find it, can you? It's just usually the case. But there's definitely a calibrate menu on it, and I went into that, and as I say, I unlocked it using the secret code that I have, and I managed to get into the calibrate menu, and then I managed to unlock it, get into it, and then try and calibrate it, and it instructs you what to do, you see, with the measurements and things like that. Let me just see if I can find it again, and then I can show you. Okay, so talk about can't see the wood for the trees. I found out where we need to go from the spectrum display here. We go to utils, and what I couldn't see is when we go to where is it now? That was it. I was in this menu before, talked about things like power on settings and things like that, Well, this little arrow here, I just missed that. So if you press that, then you get this menu here, and the diagnostics, there's calibration and factory, whatever that is. Can't see it through the camera. What does that say? Oh yeah, front panel tests, calibration, diagnostics. So when you go into calibration, for example, it goes into this menu, and basically you can go into different things now. I've done it so it's on like a timed thing. So utility, I think you can select a calibration, but it's unlock, that's it. It's this button here where you lock and unlock the menu there, in order to get into the calibration features, because otherwise, you see, they're all greyed out. You see, when you go into calibration, all these are all greyed out, so you can't do anything. So you have to lock, unlock, and then you have to put a code in. So then you have to do instrument unlock, because it's locked. So you press instrument to that. Anyway, then you have to put in this password, which I've got written down here somewhere. I just figured it out myself. I didn't read about what this code was. I just faffed about with the instrument until I managed to get around it. But it's not a secret code. It's just 1 2 3 4 5 6. Believe it or not. So anyway, 1 2 3 4 5 6, and then press that. Oops. Have I done it wrong? Oh, that's it. That's another thing on these instruments as well. Enter is this key here. So 3 4 5 6, and then press enter. There we go. So now we're in like Flynn. So we've got all this information on the screen here. Anyway, you can go into you can set a password, obviously. Well, so if somebody's done that before you won't be able to get into it unless you can figure that password out. Serial number unlock as well, there's all that feature on it. And now we've got under calibration, now we've got these options here, you see. Local oscillator, frequency standard, and then we've got the front end. And I went into the front end, and this is where you can set up the RF levels that are coming in, because you've got, as you can see there, we've got a power reference, which sets up, you know, obviously the reference power attenuator, and then we've got the high power frequency response, low power frequency response, and mixer loss. So you can sort of set things up in there. And I was trying to follow the instructions, because basically it says, for example, if you go into for example this, it'll then say under this function, it says apply a frequency at a level to low power input, and then press enter to continue, you see. So enter exact level, so that's what you put in. Then you go through this timed sequence of it measuring it, and then it'll then store the DAC in memory, and then you move on, advance to the next test. So that's a little rundown on that. But what I'll do is I'll just come out of that if I can. And now you do that. Exit. Here we go. So that's what you can do. You can do all sorts of things with it, you know, go all the way through the calibration menu. So I sort of got my fingers crossed that it'd just be needing a bit of a calibration, you know, and then that way then I could have got it working. But it's not as simple as that, and we'll see that when we get inside as well, what the issues are with it, because as I say, there's been numerous people having a go at it. But back under the spectrum bit, we've obviously got the 0 dBm signal that I'm feeding in at 2 gigahertz at the moment. So these are the sort of parameters that you get, that you can see. So you've obviously got your frequency, your span, narrow bandwidth, window, FFT sweep and size, your RF input level that's currently set for the attenuate input switch, the attenuator levels and all that. And then you've got your triggers, your average, your status and your center frequency, and that's that. And then under the analyze function, then you can go into further detail. And obviously there's quite a lot of menus as well down here. IQ data, frequency span, so you know you can adjust the frequency span to say, I don't know, 100 kilohertz in this case. And then you can look at the signal in more depth that we're injecting in. There's the measure, and then obviously down here we've got Blackman Harris, N filters and things like that we can select. All sorts of different filters. Gaussian filter obviously for GMSK or GSM modulation, fixed 1%, variable, so many things there under that measuring. Don't know what's under display. Vertical scale, so you can then change that to your different limits. Obviously it's normally set to 10 dB, or you can have it at 20 dB. And then dB units as well, dBm, dB microvolts, dB millivolts, dB volts and dB, so I'll leave it at dBm. You've got a print facility as well. You can do a single, so basically if you press that button there, a single, it'll do a single sweep. If you press it on repeat, then it'll go back to doing that. And so much you can do with it, you know. It's such a put that frequency span back to 1 megahertz, so quite a useful instrument. I dare say in its current state you could use it, you know, in fault finding, you know, as a spectrum analyzer mod. It would be a good fault finding tool, even though it doesn't read right, but at least it gives you an indication of a signal there, so you know it's the sort of thing that you can use with it. Anyway, we'll whip the lid off now and have a look inside and see what we can see. Okay, we've got the lid off now. Obviously the front down here, and this, as I say, somebody's been in it, because obviously these screws are all missing for majority of what's in this module here. So this looks like some kind of RF tray which hinges up, you know. Looks like as if we've got a power supply, switch mode power supply at the end here. This looks like an industrial PC sort of thing, processor, because if we look down there, we've actually got, it's an Intel 386 microprocessor, the 80386. So those were the days. And we've got the battery, 3-volt battery there for the memory backup, and then we've got some RAM as well down there too, which is these cards here, probably a meg each or something like that, back to those days, early 2000s, because this will have been roughly when this machine was manufactured. So I'll just see if I can write it up and then we can have a look further. Well, I've just noticed there's a little sticker on this processor board. If I just move the thing down there, there's a, right down there, there's a sticker, and it says, I think it says something about an IC being replaced. I can't get the camera to focus on it, I'm afraid, but that little sticker there says fixed, and basically it says that the IC on the computer board, one of the ICs, has been replaced. So there's been numerous repairs done on this, as well as whatever's under this tray. So we'll have a look at that next and see what we can find. But looking at this, obviously the switch mode power supply, all the outputs are fed to this, what looks to be a power conditioning board, which looks like as if it's got some kind of obviously inductive capacitive components there that are obviously doing a lot of the smoothing, etc., and keeping the supply. There's no regulator ICs on there, but it looks like it's keeping the supply nice and smooth and noise free, and then these individual cables then go off to different boards to supply power to the different modules within it, and that's what that board does there. This one looks like as if it's some kind of power distribution as well, but this board here I think is the GPIB board and the options serial card, etc., for the output on the back, which we'll look at soon. We've obviously got as well the LCD module as well, just sat at the front here, and the keyboard, rotary control optical encoder down there, and then we've got some RF module here on obviously we've got the N-type sockets as well, so they're down there as well for the high power and low power inputs, which are those SMAs that you can see there. So there's a few little things. I think we'll take this screening can off next and have a look and see what's inside that. Alright, we've got the lid off now, so we can have a look inside. So I've got some nice filter arrangement in the middle. We can clearly see an RF path in on the top here. Right hand side goes in, goes through the filter, and then comes out the bottom to this circuit here. So we've got some kind of RF amplifier thing going on here, and mixers, I think, with the look of those, possibly. Not sure without looking those numbers up. Definitely got a Ballon mixer here going off, that little thing. So looks like these potentially could be a voltage regulator IC, but these, I'm not sure what they are, to be honest with you. But they look like mixers to me. Could be wrong. Some mixing going on there, some kind of local oscillator. We've got crystal, and I think that's like a little local oscillator LO that's running. There's a lot of lattice semiconductor ICs on these, lots of chips. So I think that might be the synthesizer or something of that nature. Could be wrong, but might be worth looking those lattice chips up, seeing what they are. Some more power conditioning caps, something going on around here, some signal processing. This could be the output from that LO after it's been conditioned. A bit of a power supply section, and obviously, so it's like some kind of filters we've had a look at before. And this section up here, got a filter here, I think. SAW filter, possibly. It's got plenty of connections on it anyway. That could be like a SAW filter or something, I'm not sure. Just trying to see what it is. Oh, MCI 1 point, or whatever that is. Not sure, but it's got plenty of connections on it. Lots of RF grounds. There looks like 2 signal inputs there. 2 signal. Looks like we've got 2. This could be a mixer as well, to be honest, but we've got 2 there and 2 there, unless it's some kind of divider, maybe. I've got some relays. We'll look at them. More power conditioning with these inductors and capacitors, and again with a signal there which is coming up from this area, so this is some signal processing that's done here, this area too. That's a little look at that. We'll see if I can get the module out and hinge it up, and that way then we can perhaps have a look at the underside of the module. But might be worth having a look at that, see what's on the underside, if there's another can there. It looks like it's all solid anyway. So we've got a module here that does something. Looks like that's some kind of an oscillator or something, VCO or something like that. With again this power conditioning board, we've got the voltage from the power supply from the this board here that distributes power. We've got that coming down to this board, which then we've got another ribbon cable leaving that, so that's some kind of power distribution board. Various outputs as well that tells us that that's level control. Not sure what that one is. Baseband input, and then got quite a few things here. I&Q inputs, I&Qs as well. So yeah, there's quite a bit of processing goes on there. I've taken these cans off as well that were on these modules so I can have a look and see what's there, but as you can see there's a fair bit to it. Okay, so this is the underside of the unit now, and as we can see, got quite a large module that covers the bottom. This is the microcomputer sits in here, and the power conditioning boards, and that's the switch mode power supply. But just interested in the RF paths now up here, because if we just get some more light in there, we've got up here somewhere, if I can just get that seated nicely with let's have a look here. We've got the RF piping coming in here from the the high powered RF port just there, and that's a low power, and the high powered one goes off and disappears off down there somewhere. So I'll be interested. Looks like it goes to this module, I think. I'll have a look at that. And the low power one goes into this, which is this coax here. This pipe goes in there from the front end type straight to that. So that looks like it could be either an RF switch or probably a step attenuator. I think that's a step attenuator, the look of it. I see a control ribbon cable down here that sort of controls it, I think. Not sure what this is, this RF component here. Looks like got a module attached to these screws, got a feed through here, looks like it's powered. I wonder if it's some kind of an oscillator or something, maybe it provides a reference power. That's probably what it is. It probably gets DC level to there. It doesn't look like it's got an RF coax on top. I'll get my fingers round. Oh, it does. It's got an RF coax on top as well, going in right at the top. I can feel. So I wonder if it's some kind of a switch or something. It's definitely getting power there, and it's on the output of this. So that'll be interesting to have a look at, see what that is. There's another RF module down here, which obviously the coax goes to this step attenuator as well. So we've got again another module there bolted to this chassis, and that was quite an extensive RF module. It's got its own supply there with that connection. This ribbon cable here, which is the DC power supply connection, and then we've got RF going in there, and not sure if there's something going off at the top. Couldn't see, don't think so. So I wonder if that's where the reference power is produced, perhaps, because it doesn't appear to be, if I reach round the top, there's no coaxial cable connecting to the top of that module. So I think that's where the reference power is produced to self-calibrate. So that's where the calibration standard is, basically. So yeah, we'll have a look inside this module now and remove all these screws just to get to that side. This hinges as well on a hinge. There's these screws you undo and it comes up as well, but I'll just take this cover off first before we unhinge it, because I think there's more RF modules at the back of this as well, so we'll have a look at those too. Back soon. Okay, so we've got the screening can off now, the bottom module now. Some interesting parts here. We've got obviously RF output. It looks as if there's only a single RF output on this module. When this is released and hinged back, that's the only thing that it does. So it's like local oscillators, it says here. Local oscillator. But these are interesting devices to keep, because these can be used a lot in various test gear, including Road and Swartz. These little ICs. Now I can't really tell you the part number on that to look at it under my magnifying glass, but these mimic ICs are quite commonly used. There's another one just there, look, and they're quite useful to keep because you can buy them still, but obviously for free there's nothing better than that, is there? But these amplifiers are quite useful to keep, so that's always worth having a look at. Down here looks like as if, again, analog devices. I think that might be a programmable divider synthesizer, possibly part of the phase lock loop or something. We've got some LM series LT voltage regulators, power conditioning, more an LM voltage regulator there with the look of it. Can hold the camera still. And more power conditioning capacitors, so your power rail across the bottom. So I think that's how they've done this circuit board, is that you've got all your power conditioning etc. in this sort of area all the way along down to there, and then up this way as well, which you can see there. But there's a lot of analog device stuff, a lot of lattice semiconductors, quite a bit of that too. And I'll just see whether I can pull these cans off. I might need a screwdriver to just lever those off, to have a look underneath and see what's what. In a bit of a butchery at doing this, but see whether we can get this can off. Have a look in there. What could possibly be lurking in there? Looks like we've got some they're interesting. I don't know what that is. They're weird. Inductors, some kind of switchable filter, I think, with the look of it. Got capacitor strip line, inductors, something coming in the top, coming out on the bottom. Might be an oscillator or something like that as well. Could be some kind of like Colpitts oscillator. Let's have a look at this, see what's under this one. This might have some secrets. That looks like some kind of a local oscillator of some description with a crystal up here as well. Looks like we've got a adjustable capacitor there as well with the look of it, I think. I think there's a preset scroll in the top of that so you can adjust it. So there's quite a bit to it really, you know. There's as I said, voltage regulators tend to be around the outside, all the way around the outside. So there's quite a lot of voltage regulation going on. We've got a IC there. All kinds of different ICs. Plenty of surface mount. These relays are useful to keep because a lot of these relays are used in RF attenuators, in different types of equipment. Road and Swartz are quite high users of these type of relays. A lot of these, they're not plastic as such. The RF relays have got like a metal can underneath with the special kind of relays as well. They just need a pulse of DC sometimes to latch in a latch state. Again, down here in this section we've got some of those ICs again that I was telling you about that are really useful to keep. These mimic ICs are very wide banded. Some varactor diodes there as well, which I think is that, or no, it's another IC, again another mimic. So scattering of mimics all over it. Another one there, look. So again, just a standard sort of configuration of a supply line. When we look at that a bit closely, we've got a supply line, a resistor in this case to the supply line, which is here, a resistor across, and then we've got a capacitive decoupling in and out for DC bias, and the emitters go straight to RF ground. What is the collector of a device, or the source, is to a resistor. Sometimes it's to an inductor, other times it's to a resistor, and then the same down there. This one's got an inductor on it down there, look. So, you know, different configurations. There's all sorts of different things, whereas here as well we've got that sort of common mode where we've got the collector volts here going to the collector of a device via these two inductors, RFCs, radio frequency chokes, to then supply power to the, what is the collector of a device. The base, or the input to the mimic, is via a decoupling capacitor, and then of course on the output we've got a decoupling capacitor there. DC blocks basically. And if it were transistors, RF bipolar transistors, they'd have biasing arrangements on them between the collector and then the base. The supply rail here that's coming would have then a resistive coupling, which would then go down to this base of the transistor to bias it, but as we can see here, that doesn't exist in this case. So it's a mimic IC which don't need external biasing. The same there with that one. We've got again those two blue radio frequency chokes, RFCs, onto what is a collector, or pin 3, which is where the supply to the device is given. And obviously on the base, on the input, there's no DC bias again, so again that's another mimic IC, otherwise it would have biasing, which it doesn't, so that's another clue. So they're very useful devices to keep. You know, you can make lots of wideband amplifiers out of them and all sorts of useful gadgets and bits and bobs, so always worth keeping. They're so expensive to buy, a lot of these components that you get in these, so that's why I tend to keep them. I have a big scrap pile full of boards and things like that that I can rob bits off. So yeah, interesting. We'll have a look at the RF modules now at the front, but you can see here as well the LCD display module is nicely seeable now with its enclosed backlight, driver board, and the actual module itself, as well as a keypad assembly up here. So we'll just hinge this out now, and we'll have a look, see what's behind it. Okay, so we've hinged it out now. We've got a module there which we'll have a look at in a moment, but this is the underside of that module. So when we look here, we've got what appears to be the 10 meg reference oscillator, which is this device here in its oven. So that's a very useful part, very expensive part to buy as well, that. So it looks like that's a reference oscillator PCB. We've got some more chips there as well. They could be read relays, may not necessarily be ICs, those two. They look like it because they're the RF outputs there to those connectors, so that I think they're read relays, RF read relays, so they're quite useful. So that'll be like the 10 meg distribution board, and then of course we've got looking at the supplies to that, I think we've got a supply to that which may come in somewhere. Perhaps it gets its supply from this board here perhaps, I was looking to see whether it was something that was easy to wire up. We've got a wiring loom underneath, but I'm not sure if there's a connection underneath. Now it goes under there, so it must get its power from that loom there, and then this this module here. That's a useful part to have and to keep, because a lot of test gear where the oscillator goes off frequency with age, you can obviously use that module as a spare part then. So that's very useful to have. This again is looks like we've got the supplies coming in here from the power supply, some more DC conditioning voltage regulator IC, got one or two other little bits and bobs of ribbon cable that goes out obviously to connect to the other side here of things. So that's that area. That looks like it's some kind of power conditioning board is this, and got an RF connection here as well, which is interesting. So there must be something going on there as well. Must be some signal processing perhaps. Again, there's another IC lattice again, semiconductor. I'm not sure what that one is. So there's obviously some signal processing on there, not just power, which is hence the reason why we've got that cable. So yeah, we'll have a look at the rest of it, the other modules now that are inside. Okay, as to the RF side then, we've obviously got the two N-types there. We appear to have two modules. I don't know if you can see, there's one above the other. There's one module that's just slightly larger, which is up there with that SMA on it, and it's actually a bit longer. It comes down to here where the top of this module is. It goes into it. So I think that is the step attenuator. The top of this RF module here goes straight into the bottom of this module up here. I can feel it with my finger there. There's a SMA connects in there, and then the other SMA is there, look, just under there. So I think that module at the top up here, which you can barely see, this where there's that line there, the module that's above it I think is the step attenuator module. So, and I think that's what that is. And the module beneath it, which is this module here with the 4 SMAs on it, I think it's an RF switch. I think that's what that is. So it selects between the high power and low power port. But basically behind here, I just feel with my fingers, yeah, that's it. So we've got an RF coax which goes up to this module here as well, which is interesting. Little gold module that comes around and connects to there. This here connects to this N-type here, and that N-type there, that goes up and connects to what looks to be the very top of this gold module. So that coax there connects to the 40-watt N-type and goes to there, and that's got a wiring loom going into it. So I wonder if that's some kind of pin diode attenuator of some description, possibly. But we can have a look at that in a bit more detail soon. This module here to me looks like an RF switch, this one that connects into that step attenuator module, which is just above it. So looks like that's how it does it. As I said earlier, I think this is a calibrator. This gives a fixed output signal then for calibration reference into here, and then it can switch in when you do a self-calibration routine, the calibration internal. Following that, coming into this module here, these two, we've got a coaxial cable which when we look at it, it goes through a little hole, and it's just inside here. You can just see my finger there. It's this coaxial cable, and that goes to the step attenuator module at the top. So I would hazard a guess, although I can't see any DC supply to this, it could be getting a DC bias in from there. Potentially that could be an amplifier, an input amplifier. It could also be a attenuator, it could be a filter. I doubt it'll be attenuator because it'd probably have its own separate wiring loom. It's probably supply provided from this module that comes through, and it's probably an amplifier. It could be a filter as well, you know, potentially could be a machine filter, which only accepts a particular frequency range, so I might be able to look at that a bit later. This module here, it looks like it's programmable. We've got the data loom connecting to it, which will carry supply, serial clock, serial data, and ground. We've got 2 RF. This blue cable goes out to the back of the instrument down there on the back panel, and then there's a link through to this next blue cable here, which then goes off to obviously this module that we've just hinged out, that we've been looking at. So that's the IF link. So I think this is some kind of mixer. I think this is a local oscillator in. That's the RF from the front sockets after it's undergone attenuation, etc. And then it mixes in here, and that's the IF output, because as I said, the blue cable's identified as the IF output. This coaxial cable that I think is from the local oscillator, that goes off down underneath down there, so I think it gets its possibly might come back and loop back, because the IF input to the to this module is at the back there, that blue cable, so that goes into that entire module. So this must be the local oscillator feeding, so that might be a mixer of some description. Now it looks like potentially it could be a 2-part module. It might have a mixer in the first stage, and in the second stage some kind of switchable attenuator maybe, because of this data cable here that's coming into it. So that's not just carrying DC supply, that, and it's a dumb module sat on its own. There's some data programming going on in that, so it could be that there's a pin diode attenuator in it, a programmable pin diode attenuator which is switched in and out. There could be switchable filters using varactor diodes as well, potentially, to tune it, to reject certain frequency images, things like that. So there could be all kinds of things going on. They might have to have a look at that a bit closer and see what's in it. So yeah, we'll have a look at this module up here, because this is the thing that sets that 40 watts power from N-type, the high power, and it's only a little tiny module bolted to the side here, so it'll be interesting to see what that is as well. It's got like a loom connecting to it, so because it doesn't look like it's like a 20 dB pad that attenuates the RF before it gets anywhere. So we'll have a look at that next. Okay, so that's that module down there. It's just got 3 wires, that's all, that connect to it. If we have a look more closely, there's just 3 wires. You can probably just make it out, perhaps. Not sure if get a bit more light coming in there, but you can see 3 wires, 3 or 4 wires go into it. So that obviously goes straight then to the, as per this coaxial cable, going straight into the N-type on the back. So that goes there straight into the N-type socket, which is obviously there on the front. So that's the high powered RF socket, so that goes straight into that module. So I think this is a pin diode attenuator. It could contain a 20 dB pad in it, a resistive pad, and then pin diodes after it, because as I say, this can deal with 40 watts of RF power maximum, so that's a considerable amount of power. So this could be a RF attenuator pad with 20 dB resistive pad in it, or whatever, or 3 dB resistive pad, whatever, and then after it, then it could have, in theory, pin diodes as well to electronically attenuate it in fine increments, fine steps. So that's potentially why there could be these 3 wires. Then the output of that then is fed off then to the RF module, the switch that we were looking at earlier underneath. This is the top side of that module, because underneath is the RF switch down there, and then the top part here, this is actually the confirmed it there, so to speak. This is the step attenuator, because we've got the DC control as well as the programmable control, and this ribbon cable coming in. So this is a standard Marconi step attenuator module like you find in most radio test sets in the Marconi range, like 2955, the microwave test sets and all the other test instruments, signal generators, things like that, that the Marconi IFR Aeroflex range catered for will have this step attenuator module in it. So that's a useful part as well. But beneath it there is the RF switch. So yeah, quite interesting is that. I'm not sure what this module does here. This looks like it's the data cable for this module that we were looking at earlier. The local oscillator from the top is one of those cables. I think it's this cable here that went to that mixer module, you know, that we were just looking at before, and that then goes down then to obviously one of these connectors. So then that I think is a local oscillator or level control, etc. Yeah. So again, not sure what's under this cam. Might remove the screws and have a look at this shortly. But this has got a few RF connections on it here. Got some connectors at the top, just these two as well. Some connectors at the bottom, so there's something interesting going on in here, definitely. Might have to remove the screws and have a look and see what's under that. But I'm not sure what it does. Again, we've got the famous lattice semiconductors as well. There, whatever that IC is. Some more DC conditioning. We've got the power supply in. The power supply on this is the yellow wire carries minus 12 volts. The black wire is ground. The red wire is plus 5 volts. The white wire is plus 8 volts. The orange wire is plus 12. And the grey wire is plus 24 volts. But on this one, they're all the same connectors, so you can measure them there on those surface mount resistors. So again, we've got the power conditioning side of things down there, and a lattice semiconductor. There's some bodge wires on that IC there. So there's one or two little bits and bobs, but not too much to talk about on that one yet until we obviously get that module out. Have a look and see what's in there. So we've taken the can off the top and everything. Interesting device here. It's Watkins Johnson device. I've just looked that up on the computer, that HMJ, I think it is 5 by Watkins Johnson there, just to see what that was, because Watkins Johnson obviously are quite renowned for making yigs, yttrium oscillators, so I wondered if it was a mini version of that at first, but obviously it's too small. But anyway, I've just looked it up, and it's actually a gallium arsenide semiconductor field effect transistor mixer. That's what it is. So it's a gas FET mixer, as commonly known as. Anyway, it's got a frequency range of 40 to 1 gigahertz, a local oscillator 30 to 900 megahertz, and an IF of 5 to 250 megahertz. And it works off 3 volts DC, consumes a maximum current of 35 milliamps. So that's a little interesting device, you know, it'll be quite useful for something. Again, we've got a range of filters here, tunable, ferrite cord, coil tunable filters. One of the famous Omron relays there, which are obviously quite useful RF relays. I think the latching type works off 5 volts DC. They're very expensive to get hold of. Got lots of nice little Ballon mixers, here, inductive mixers, and lots of other nice little ICs. Again, some of these, I think, is that one there? Maybe, maybe not. I'm just looking to see if there's any more of those monolithic microwave integrated circuits, the mimics. There's another one of those inductive mixer balance there, look, another one there. But just looking to see what I can find. See, these could be RF transistors as well, these devices, so they probably are, rather than just regulators. They might be more power related, but there's a fair bit to it, obviously. Some more inductive things going off there, RF inductive. So yes, quite interesting. Not much else, I don't think. They're the output sockets on the rear. So yeah, interesting to have a look at that. Again, that's got quite a bit going off for digital signal processing. I think this is a DSP IC. I'll have to look that up, see what that is. I could be wrong, but some interesting tech in it, you know. Quite advanced for its day when you think of its age and its production era. So yeah, very interesting. Yeah, so just looking at the microcomputer now, we've obviously got the Intel 80386 microprocessor there. In the good old days, you know, you used to get the 80386SX, and then there's a DX. One was a 16-bit processor and the other was 32-bit, because in the days this was well before the 64-bit machines were available. So we've got a UV EEPROM down here, ultravioletly erasable, electrically programmable read-only memory. So you obviously erase that with ultraviolet light when you expose this window. It all organically grows back when you when the memory map, when you expose it to UV light, and then you can reprogram it again, so it's reusable. A lot of these processors back in the day, when they were used not in an industrial computer context like this, but in a home computer, a lot of the motherboards had math core processors as well, additionally, like an additional add-on, if you like, that improve the calculation speed of the processor. Then we've got the peripheral interface input-output IC down here, which is this. Some of them had additional external to the processor ALUs, arithmetic logic units, which is again the math core processors it was commonly known as, or it became known as. The clock frequencies on these were quite low, which is probably what that crystal is down there that you can just see. That crystal is probably the microprocessor clock crystal down there. They tended to run around about 16 megahertz, did the 80386 machines, and they used to have turbo boost switches on some of the home PC machines that used to boost the clocking frequency up to like 32 megahertz, something like that, to make it run a bit quicker. And back in those days we were looking at, you know, 1 mega RAM, you know, whereas these days we're looking at multiple gigabits per RAM per stick. In those days they were like 1 meg RAMs, possibly 2 meg sticks if you were lucky. And back in those days I think RAM were about £30 a megabyte. So that just shows you the price difference between back then and now. And so yeah, we've got quite a few ICs down there, but this was the early architecture of microcomputers, really. I mean, obviously before this was 80286 microprocessor, which I think was I don't know if the 80286 was 16-bit. I think it might have been an 8-bit processor, but before that then was the 8086, which was like the ZX Spectrum, ZX80, Z80 computers had in the early days in the 70s, 80s. After this one, I think it became the 80486, because I've had those, and they did again a 486SX and DX, and then it became the Pentium one after the 486 processor, which was actually an Intel 586 processor, if I remember rightly, but then it became the Pentium marketing label on them, so instead of the 80 series part numbers. Obviously we've got the lithium battery there to back up the ROM, read-only memory, and then our RAM, and then obviously we've got the data controllers here for the data bus on the microprocessor. Of course, these days you used to have a graphics chip as well, I think, on some of them as well, a graphics accelerator chip. There were all sorts of different add-ons and things that came later on with the 80386 and range. I think the IBM PS2 machine that I used to have as a young boy, I had a 80386 processor in one of these. So it just shows you. But obviously used widely in industrial computers, probably even to this day. So that's a little rundown of that. So I can't see what the frequency is on that crystal from here, but I bet it's quite low in frequency. It might be. Oh, hang on. Might be able to see something here if I just get that wire out of the way. There's always a wire, isn't there? What's that? 14.31818 or something megahertz. So it might be running about 14 megahertz, so it might be divided down. Often they divided it down because the data buses on these were really slow. You know, if you got the serial data bus on them was very, very slow in comparison to modern day standards. Ran a lot slower than the actual processor did. Some of I think the bus speeds were like 2 megahertz, something like that, which would equal probably half the data rate of a processor could process, because that was another thing. The UART controllers on these for the serial data were always quite latent, with latency, because obviously the processor's outputting its data onto the serial bus. There was a parallel interface quite commonly found. You normally had a load of header pins for parallel printer interface or parallel devices, and then you obviously had the serial interface as well on board serial controller. So yeah, quite interesting. Old school computer from the good old days before all this stuff that we've commonly take for granted today. And obviously very good for working with Microsoft MS-DOS 5, MS-DOS 6 and 6.2, possibly Windows 3.1.1 if you're really lucky, but definitely nothing more adventurous than that. Yeah, and if I remember rightly, at the time there was, back when these computers were sort of made, there was some interesting things going on at the time. I mean, you had, back in those days, there was obviously major advances in computer manufacturing. I remember Amstrad, Alan Michael Sugar Trading, I think it was called, or Sir, what they call him now? Alan Sugar, Sir Alan Sugar. That was it. He had a company called Amstrad which made PCs, and I think they had the 80386 processors in them. He was one of the first with the home computing, after the likes of Sir Clive Sinclair, who made the Sinclair ZX Spectrum or the Sinclair Spectrum. And there was major wars between Sir Clive Sinclair and the BBC Micro men, the people that made the BBC Micro computer. And I think at the time as well, there were lots of manufacturers. There was a Commodore. I had a Commodore 64 as well. I think that had one of Commodore's variants in. There was what else? A Victor computers. That was it. I had a VIC-20, Victor Corporation, VIC-20. There was the ZX Spectrum with the rubber keys on it, and there was major wars in the electronics industry at the time. You know, I mean, there were big battles between Sir Clive Sinclair of Sinclair Corporation and the BBC microcomputer guys, but there was trying to get a market into the educational market, supplying schools with computers. And I remember at school, when I were a lad, we used to have BBC microcomputers, and obviously quite a collector's item now, running I think on the 8086. So it just shows you, you know, there's all sorts of big battles going on back then, and to try and get a foothold in the market. So very interesting times back then. Lots of characters and lots of arguments. So this is a rear of the unit. So we've got the IF link through, all the BNCs obviously for the IQ and frequency standards, etc. And baseband input, IF input, fan. This is where the microcomputer sits here. So we've got a VGA. So on that board as well, there'll be a VGA controller on the microcontroller. We've got INQ outputs here. We've got a GPIB, general purpose interface bus, IEEE spec connector, parallel again, print port, and then we've got an RS232 serial, and then we've obviously got the digital signal processing IO input output as well. There's something here which is an LVDS or something out. Could be sometimes you see SCSI drive connectors on these from the old days when they used to have SCSI drives. So, and that's your power supply section here, which is a separate module all in itself. So that's a little rundown of that. Right, so it's reassembled again. We'll just check it works. We'll plug in the 2 GHz signal at 0 dBm. And there we are. We've got the level back. As I say, it's just a shame really that it's got this fault on it, which is where when you select the markers and you put the markers on, that the marker level that shows up, and it comes on here. Markers on. Is it going to come on? So marker frequency. Got marker IQ, markers on. Oh, it's under spectrum, I think that's why. And then you go to there, by markers on. Let's have a look. 2 GHz. There we are, we've got the marker on. The RF level, you see, is excessively low, because as I say, we're inputting in 0 dBm and we're getting there minus 28 dBm for the marker. So it's obviously got a significant attenuation on the RF input, and it doesn't matter which port you use. So I think it's beyond the first stages, the RF converter, beyond that. So there's obviously other deeper faults on it as well. But it's a nice instrument, you know. It's good for keeping the spare parts and things. There's plenty of spares in it that I can apply to other SIG gens and things like that, because I do have other test equipment here that shares the same cabinet parts and power supply and things like that, so it's useful for spares as well as the screen, which they're impossible to get. So really good for that. But I'm just going to monitor the IQ output now. I've got on the rear of the instrument the INQ data outputs connected to the oscilloscope. So we'll just have a look at that on the Rigol scope down there. So if I just keep my eye on that, I'm not putting any mod on at the moment, but if I disconnect the RF input a minute, which I'm just unscrewing now, as soon as I remove the RF input, you can obviously see that it has a big influence on the signal there. So just shows the digital outputs are working, the analog to digital conversion. Not getting anything more than that at this stage, even if I modulate the carrier. So whether there's an IQ failure on it, I'm not sure, because we do have, under the analyze feature here, we've got IQ data processing, I think it is. I think that's what it says. Or can't quite make that out from here, but I put that on. Doesn't really make any difference on the, oh it does, yeah, on the scope. So that's with it off, that setting, and that's with it on. So yeah, so it does work, but pretty useless really for what I could use it for. I mean, it's obviously meant for GSM, which is long since going out the window now with the advent of LTE networks, so it's good for RF parts, certainly good for that, as we've already looked at, and plenty of scope for spares and things like that, cabinet spares, as it shares spares with another signal generator model, which I've got here, which is the what's it called now, the 2010 I think it is, signal generators. So I'll just show you what that other SIG-Gen is that it shares the same cabinet and power supply parts with. So that's the kind of SIG-Gen that it's used for parts for. It shares the same cabinet parts as it, power supply and other internal parts, so I'll be keeping it for those eventualities, any spares or anything like that that's needed. So yeah, that's what we'll use it for. We'll just take you through its boot up routine as well, and now that it's been switched off, so we'll see what it does when it comes back on. RF Digitizer. There we have it. Yeah, so that's it really, I think. I don't think there's much more we can do. Obviously it's a nice little instrument. It probably could be sold as is, you know, if I don't need it. I bought it for parts, you see, for helping service other things, but if I don't find much of use for it in time to come, I might sell it. It'll come in useful for somebody who's starting up in RF or electronics, RF engineering, in fault finding and doing basic testing, because at least it can be used for indication purposes, you know, measuring RF signals, etc. It's got quite a good step attenuator on it, good frequency range right into microwave spectrum. So no doubt to somebody this will be a really good piece of equipment to have as a sort of makeshift spectrum analyzer. Plus as well it supports digital modes as well for digital transmissions, I&Q, so that would also be something worth having for somebody. But I as I say, I just bought it for spare parts, that's all, because it shares cabinet parts with other instruments in the Marconi range. Anyway, with that, I hope you've enjoyed the video. It's been nice having a look inside it. It's nice to see something different once in a while. And if you like the video, please give it a thumbs up and subscribe. There'll be more videos like this to come. Thanks for watching, and catch you in the next one. Bye for now.